Hi.
Well, hey there.
Hey. Guess who's back?
Oh, the plant!
Yes.
How's it doing? It looks a little sad.
Yeah, they're still hanging down.
Okay.
What you can't see is this massive new growth of stalk here, and I don't want to break it. All right. Yeah.
No.
This going now, like all that's new. He lost part of his head due to a sunshine accident.
It grew quite a bit.
He did. So
Never think about these things.
Yeah. Well, the thing about this plant is that it doesn't bloom. It takes at least 2 years to bloom, and then after that, I've never seen a flower in 5 years of having these, and that's fine. I'm okay. I'm all right. I'm okay. But one day, they're gonna bloom, and it's gonna be gorgeous, amazing.
We decided we're going to do the entire talk in German, but in the type of German that you get in Castle Wolfenstein. Anybody remember that game? We had, this was back in the days of the Commodore 64 and the Atari and so on, where systems didn't have audio output. They had maybe a little buzzer that you could do, but the programmers of that game decided, okay, we're going to come up with just enough audio that sounds almost like German if you suspend reality for 5 minutes. So that's how we're going to do the entire presentation today.
So
we'll
I don't think I played Castle Wolfenstein, but I do remember playing one. Was there another version called Wolfenstein that was made for the computer?
Wolfenstein 3D.
Yeah.
Okay. That was like 94? Was that 92, 94?
Wouldn't be surprised. Yep.
Early 90s anyway.
Okay.
The graphics on it would make us all grin at this point for their resolution that would probably fit just fine on an Apple Watch with space to spare.
Mm. Pretty much my entry into computers was loading Doom up on the computers at school, like during class. And, and I hypothetically had learned that if you opened up that computer system at the school and you found 2 RAM chips in there, you could potentially remove one and use it someplace else. We have a Wild John Strand somewhere in here.
Wild John Strand sighting.
I would like to point out that he's free range as well.
Oh, crap. I got that camera thing going. I got this new system.
You got to switch to a 16:9.
I'm going into preferences. Let's go to camera.
You look like you lost weight, though. So.
How about now?
That's better. Yep. You don't look like you're crushed anymore.
Yeah, you're back to normal.
I was working at a consulting company, and we used to get together after hours and play first-person shoot-'em-up teams and try and take each other out. And there was this one person that everybody started realizing that they'd like go into a room to shoot them, they would have their back to them, and as they'd start shooting, all of a sudden their screen would freeze, and like the person would kill them and then grab their stuff and be gone. So we actually started monitoring the network to see what was going on, and this person had come up with a buffer overflow that would basically, he had everybody's IP address and he would busy out somebody's system so that you weren't getting frame updates and you wouldn't see what was going on, and he'd go take them out. So that kind of degraded into, okay, so now you have to defend yourself on the network while you're defending yourself in the game. And it was actually an awful lot of fun.
Yeah, this is legitimate network security. I don't know why we don't have a webcast on this.
We should. We should have a webcast on this. I like this idea.
Playing against somebody else, and you call that person's significant other and ask the significant other to put on some popcorn. And all of a sudden, the microwave interferes with the Wi-Fi at their house, and then you can kill them and take all their stuff.
What kind of world is it where you could call my wife and say, Erica, put on some popcorn, and she'd go, sure.
Sure.
I would so do that if you had an internet connection at home.
So, Bill Stearns, we got Password coming up. You got that webcast, and then you did the workshop recently on how to give talks. And what can't you do, Bill Stearns?
I cannot do a damn thing with my car. And this is the sole reason, well, this is one of the many reasons why Chris Brenton has zero respect for me whatsoever. When something needs to happen on my car, I find a dealership and I say, hey, fix this.
Oh, no, Bill, that's not the reason I have no respect for you.
I know. There are so many on that list. It's really hard to pick.
Yeah, exactly. That's like 7th on the list.
It just keeps growing every single freaking
Big
day.
list. It's books. It should be a book. People Chris doesn't respect, and why?
Yeah.
Of course, big question for Bill. Which would you rather try and fix yourself? Your car or a Windows system?
My car. I would learn every single component of my car in order to avoid fixing a Windows system.
There you go.
Oh,
Hey, Bill, down there in that CAN bus somewhere, it's Linux. Boy, I'll come the tools and the wrenches.
that's right. Keep digging. I'll be logged in 5 minutes. We will have this sucker fixed. It amazes me.
Given the embracing of open source, there is a rumor going around that Windows may actually end up built on Linux at some point.
And that's not even a joke. I've been hearing that seriously. If you're Microsoft and you're seriously looking at it, you spend all this money on crap, at some point somebody's got to sit down and say, why are we writing an operating system? I mean, these crazy jackasses out here, like this Bill guy, they're literally creating one and supporting one for free.
Yeah.
Yes.
Yeah.
But is it as good as ours? Better. Will it run on mobile devices? Yes. Ballmer's like, this sounds like a great idea. So
Will it run in space?
Will it run in space?
Yes.
Yes.
There's a link in, what channel did I throw it in? I think it's in the Zeek channel. It's definitely in the Zeek channel. It's also in the one of the threat hunting channels. Oh, I hate it when I can't find things. But
You're all set, Chris. It's in chat and GoToWebinar.
Perfect. Yeah, so one of the things we kind of ran across, and I got to thank Mr. Keith Chu for this. He was the one who kind of ran across this and basically said, dude, I'm seeing this really weird thing and I just don't understand it. And as him and I started digging into it, it was like, wow, this is like kind of bad. Long story short, Zeek forgets about connections after 5 minutes. So if you have a connection that starts passing packets and then pauses, if it pauses more than 5 minutes, Zeek says, well, I'm bored now. I'm just going to write that out and forget about it. And when the session starts back up again, it handles it like it was a session. The example I kind of give in the blog is, hey, here's a session that took place for 19 hours. So if you're in looking for long connections as part of a C2 hunt, you would be interested in this. But Zeek is only reporting it communicating for 4 seconds, and that's bad. We also kind of talk through how to fix it. So if you're in, oh, by the way, I go through this with Zeek, but trust me when I say this isn't just a Zeek problem. Anything that's trying to do reassembly and kind of mimic endpoints as part of its security probably has this issue. It behooves you if you're using Zeek or Bro, go through the fix we describe. If you're using something else that's a similar tool, it behooves you to go in and test it just to make sure you're not running into the same thing. And if you are, hey, go back to whoever created the tool and figure out how to fix it.
Absolutely, and that goes for firewalls, routers, network IDSs, network IPSs, almost anything that has to watch traffic go by and make decisions about it. It's amazing how many low-end routers used to have timeouts in the 5 to 10 minute range, and you'd find that connections would just die partway through because they were just sitting idle too long.
Actually, that's a good point, Bill. I should pull out Snort and Saracata and kind of run through similar. I'll bet we run into kind of similar issues with that. Radis was asking in the Discord channel, is this the same issue that was discussed during the threat hunting class? Absolutely it is. The difference is that I actually give 2 different ways to fix it instead of just one like we did in the threat hunting class.
We also had a question last night on Discord about whether this would drive up the memory. And there is a small chance that it may.
Yeah.
And so my best recommendation is if you're looking at a very heavy network, don't turn it up to a full hour right off the bat. Move it up to maybe from 5 minutes to 10 or 15 or maybe 20 minutes. And then watch the memory usage of your software and also the CPU utilization. Make sure that they don't go too far above where they were before. And then if that works fine, extend it out to 40 minutes. Try again for a couple days. Make sure things are still stable. Then try it for an hour. It might take you a week to do the entire transition, but it also means...
blow that off. Just do an hour and be done.
change it to 3 hours right now. Come on.
Seriously, I think the concerns about using extra memory and CPU and everything on this is drastically overblown. I think the only time Zeek is really doing this is when it's doing it incorrectly, meaning unless you've got a Zeek system with a high level of packet loss, you're losing like 30% of the packets that goes by. The chances that neither end of the connection actually closes the session is kind of, it's a very rare outer case. The only other option might be Zeek is dropping a ton of packets and you might miss it that way. But hey, before you worry about this, fix the reason Zeek's dropping packets. That's giving you more problems than this will.
And we have blogs about that too.
I wanted to say welcome, everybody. Thank you so much for coming. This is another webcast where we're talking about the free tools that we offer at Active Countermeasures. A couple of quick notes. Once again, the free tools are important to what we do at Active Countermeasures, mainly because our main goal is trying to give back to the community as much as we possibly can. And Passer is really no exception. And I am pretty sure, Chris, that earlier variations of Passer from years back, as Bill was Dr. Frankenstein creating this thing over time, how many routers at your house did you say that Bill destroyed, you think?
Bill has melted down at least 3 routers at my house.
Yeah. So, and that's good because we got that done years ago, right? So The idea of Passer is how do we actually do inventory in a way that's sane? And Bill, correct me if I'm wrong. This really seems like, for a while people would talk about P0F and they'd be like, it hasn't been updated in a long time, hasn't been updated. You were, in fact, constantly continuing to add new functionality to this concept of passive identification of services and systems and network connections and all of these different things, right?
Yes, we've had regular work going on. I'll talk a little bit about the history, but Passer is about 12 years old now, which is 4 years older than my dog. I have a little bit on the history right at the end, and I think I wanted to leave that just in case we started running short on time. But we'll talk about where this came from and how the project has grown.
Fantastic. And we have people sometimes that come to these webcasts are like, well, how can I convince management that having an asset discovery tool is something that we need? If you look at almost any compliance framework today, and I'm sorry, I'm talking about compliance, any compliance framework today from the Center for Internet Security Controls, that's really weird for me to say that, or the NIST framework or ISO, inventory is huge because you can't secure what you don't know is there. And Passer is one of those tools that will absolutely help you with that. So as I mentioned, this is a tool that we offer at Active Countermeasures. We have a commercial tool. Check it out. We're going to change the name to AC Hunter. There'll be another webcast about that in the future, which I think is the world's best network threat hunting tool for command and control. And if you're interested, please just type in demo in the chat window on GoToWebinar, and we'll get a hold of you, and we'll set up a demo and show you what you got. But as for right now, it's all about the free stuff. So, Bill, are you ready?
You got it. Absolutely.
All right. Take it away, sir.
Hey, thank you, everybody, for making the time today. I really appreciate your coming in to take a look. This is a tool that's been out for a while, but it's still one that people aren't aware of. I wanted to walk through a little bit about the tool. Real quickly, my name is Bill Stearns. I work with Active Countermeasures. I work with Black Hills. I work with Wild West Hacking Fest. I've been a computer security instructor for longer than I can remember, and I've really enjoyed working in the open source community. At one point, I was asked by an employer, what projects have you contributed to so that we can understand, which ones are outside of the scope of your day-to-day work? And I started jotting them down. It took me all night. I had 1,003 projects that I had either written or contributed to or helped out with on some level. But the nice part is that I get the benefit of all of the people who've come before me and all of the projects that have made this possible. So hats off to everybody who's worked in the open source community, and thank you so much. As for standing on shoulders, I stand on many, many, many shoulders, and I appreciate the libraries and the tools and the operating systems that benefit me directly. Passer is a piece of software that we offer for free. It's a network sniffer. Its job is to run without any interaction, without any active scanning of a network. It just sits there. It literally doesn't send any packets if you install it the way we recommend. If you leave off one step, it may actually try to do DNS lookups, but we strongly discourage that because it slows the process down. So literally, Passer will sit there for days, weeks, or months, listening to traffic coming off your network. Its job is to tell you what systems are on your network, what services are they running, what versions of the software are they running. Are you seeing any types of malicious traffic? In this way, it is somewhat similar to Zeek or TCP dump or Wireshark or any other sniffer that you've ever seen. The one minor difference between Passer and the tools that I've just mentioned and the hundreds of other packet capture tools that you could start up, Passer is focused on the state of a system or a service. It is not focused on show me every connection between every pair of IP addresses that have ever gone by on this network. Instead, it will tell you, I saw this computer make a web request, and then on a separate line, I saw this computer reply. And so we have a web client and a web server, for example, but it won't show you every single connection that made up the network traffic for that day. For that type of goal, we still have Zeek available. It handles that job very well. We have TCP dump if you want a lower level. We have Wireshark if you want lots of network analysis and deep capture. All of those tools still work. Passer is focused on the state of a system or service. We'll see it in just a minute. Passer is also non-interactive. Like many network sniffers, you simply start it up. It saves its output generally to a file where you can see it later. It's not something where there are lots of buttons and whistles and GUI elements. It just runs. So let's take a look at the kind of things that it can find. First off, you'll notice the output. It's very basic. We'll talk a little bit more about that in a couple of slides, but what I want to point out is that Passer is there to show you the state of an IP address. So for example, this IP, 36.110.185.107, has a TCP server. That's what that two-letter acronym is for, listening on TCP port 80. And I know that it's listening because that's listed here. If it was somebody who tried to connect to it and it was closed, you would see obviously closed instead. But the interesting part comes when you match up Passer with the databases that the Nmap project has put together. Nmap has put together a bunch of signatures that say, when I'm looking at network traffic, please go into that and see if you see these particular elements, say, of an HTTP conversation. And based on that, Nmap can report that it's seeing Nginx version 1.6 running on TCP port 80. And oh, by the way, there's some more version information that comes out as Igor sysoev. I'm assuming there's somebody named Igor involved in the project, and that's where that signature comes from. And I said this was Nmap, but the really nice part is that the data files that Nmap provides, Passer can use. So even though Passer doesn't actively send out the probe that Nmap would have sent, it can still use these data files to extract the package name, the version number, the operating system it's running on, what libraries are required. So for example, down here, we can see that this system, 37.1.208.56, is running Apache HTTPD version 2.4.6, and it's running on CentOS and requires the OpenSSL 102K library on that system along with mod FCGID. Remember, I didn't do all of this work. This is courtesy of Nmap, but the nice part is you don't have to do anything extra to get it other than install the Nmap package. You never have to run it. And if you're in an environment where people say, well, you can't put Nmap on that system, no problem. Just bring down the data files that Nmap needs and leave the executable off. You can still do it that way. We also show a server here running on UDP port 53. This is 1.255.106.60. And we note that it's an open server and it's of type US, which is UDP server. UDP, to be fair, doesn't technically have servers and clients, but you can think about how there's a query made from one machine to another, and in that sense that you have a client and a server. What else does Passer find? Well, routers. So for example, these all happen, or most of these happen to be IPv6 addresses. I do write them all out so that the IPv6 address, even though it's very long, it will sort correctly, and you can pull identical systems together. We'll see that in just a minute. So what I'll do is I'll report that this particular IP address, FC:::1, is a router. And the reason that I believe that is that it sent me a host unreachable packet. So in this column, what you see is essentially the reason why I believe that this is a router. And same here, host unreachable. This router, FE80::3BDC, sent me a neighbor advertisement router flag. That's fine. There are different ways that we can interpret that this machine is a router from what we see on it. If in IPv6, when you have a router advertisement packet, the nice part is there's a whole bunch of extra data that comes in that router advertisement that we can pull out. So for example, this particular router, FE80::3BDC, says that its network is 2601.18c4200 blah 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 /64. And here are the two DNS servers for this particular network, so that a client connected to that network can automatically set their own DNS. This is really handy now because as you're learning about a network, you can learn where this information came from. And in this case, it's the main router for the building. Time to live, we believe that 62.115.134.6 is also a router because it sent back a time to live exceeded packet in response to this machine sending out a network probe. In other words, this machine was running traceroute, and this box said, oops, I'm on the path to where you're going, but I'm not your target system. In addition to servers, we can identify what machines are clients for a certain port. So I can say that 10.0.0.41 made outbound connections to some computer, we don't know which, and using on port 22 TCP, which was SSH. Likewise, we can see that we have clients for TCP port 80, web servers. We have a RIP client on UDP port 520 and a CareGen client on UDP port 19. What these are isn't terribly important. You can learn about them as you go. There are lots of references on the internet for what these individual ports are, which ones are malicious, which ones are benign, and I've got a couple of clues coming up as well. The other thing that's kind of interesting is that by watching the DNS broadcasts that happen on a network, I can find devices on the LAN that are advertising themselves. In this case, 10.0.0.179 is advertising itself as a printer, and in particular, it's a brother MFC J5830DW, which happens to be sitting over to my left. And similarly, I have an Apple TV, and it broadcasts that it's an Apple TV every once in a while. So one of the nice parts is, even on just a basic connection, if you can come up with preferably a span or mirror port, copy port, or tap, depending on how your network is set up, you can learn a lot about what's on your network with very little additional work. These facts just come out. The most recent module that I've put in is looking for different types of malicious traffic. There are lots of things that are flagged in this way. I won't go through all of them, but I wanted to talk about a few. First is that this machine, 122.124.243, was caught trying to connect to a port that you don't generally want open to the internet. I don't have the additional line that would have probably been just before it that shows what the port was, because I was just trying to show these malicious lines. But for example, trying to connect up with port 23, Telnet, people shouldn't be using that anymore. That's not something you should have crossing your perimeter. So we would flag that. There are some other ports as well, and we can go over them in chat at some point in Discord if you're interested in these. 579.65.7 was scanning our network. It was trying to connect up to a lot of ports or a lot of hosts. If you get a situation where the traffic coming in looks like it was spoofed, i.e., the packet that arrived had this as a source IP address, 23.95.213.110, and it looks like it's coming in and making a NTP request of me saying, please give me the list of all of your peers. Well, in fact, that type of request is something that machines shouldn't be doing anymore. And in almost all cases, this is very likely to have been an IP address where the source IP was spoofed. In other words, some computer totally different from this machine, the .110 address, put that address in with the hopes that thousands of computers around the internet would all respond with, oh yeah, here's my list of NTP peers, and throw them back at 23.95.213.110. So if you were on the pre-show banter and heard us chatting about how you might take out your buddies while you're playing a game, this might be one of the ways you can do that. There are machines that will go through and scan for SIP clients or voice over IP. In this case, we have 37.49.231.38 asking, are you a SIP server, i.e., are you running a voice over IP application? And it also lied and said its source IP address was 1.1.1.1, and it was talking to 1.1.1.1, when obviously that's not the case. So this machine is a SIP scanner. And finally, there's some additional lines that don't really fall into the above categories. We'll list off the MAC addresses of your systems. In this case, IP address 2601 blah, 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 5F23 is listing MAC address 7C0191A2FD6B, which is registered to Apple. So while this only works for the machines on your network, remember MAC address broadcasts and queries and responses don't go beyond a single LAN. This helps you identify who the manufacturer of a particular device may be. Similarly, we have DNS answers. Here's an A record. Here's a CNAME record. We also have PTR records like this one down here. Remember, Passer isn't making queries to look these up. All it's doing is watching the DNS traffic go by and extracting the answers that were already requested. So somebody on your network asked, who owns FE80 blah, 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 1F6F? And the answer came back, oh, that's Bart's iPad device info.tcp.local. In fact, this iPad actually broadcast that answer itself probably. But there may be more details on the end, of course, with more information about that system. Okay, So that was the kind of quick intro. Let's talk a little bit about how the tool works. I've tested this mostly on Linux and Mac, and we've had some very good luck with people using it in both platforms. It should work on Windows. If you were watching the initial pre-show banter, you'll probably have overheard that I'm not a big fan of Windows, and I don't really want to spend a lot of time on it. That said, if it's important to you and you'd like to get it working on there, I'd be very happy to chat with you and work with you, help you figure out what changes need to be made to make it work stably and well on Windows. It does require the Python scripting language, and in macOS and Linux, that's automatically included. On Windows, you'll probably have to go and install it. And also the Scapy, S-C-A-P-Y, library. Scapy is a packet analysis library that can be used either for sniffing packets, as I use it for. It can also be used to create packets. So if you're trying to send a very carefully structured packet at a device to tell whether it's vulnerable to a particular attack, you can use this language, which is part of the Scapy library, inside Python to generate these packets and send them as needed. There's a lot more to Scapy that I won't be covering today. It's a wonderful, powerful project in and of itself. Because it's a packet sniffing approach, you can read packets right off of an interface or right from a PCAP file. Both work just fine, and in fact, Passer will very happily listen directly to an interface, or it will very happily read off of a PCAP file and analyze what came in. Right now, Passer is single process, i.e. there's a single Python script that runs on a single processor. There is a multiprocessor version underway. It's been underway for a long time. There are too many fun projects, and I haven't gotten it finished. But if somebody's interested in chatting with me about it and helping me pull it over the finish line, I'd be happy to talk with you about that. The nice part about the multiprocessor version is that you can actually do active scanning if you give a command line option of -A, and you also get autonomous system number and GeoIP info out of it. You do need a span port in order to see all the traffic for all the machines on your network. That said, if you've just got a normal port, you can actually do a pretty good guess on most of the things that are happening on your LAN simply because of the broadcasts. It's a great way to start. Even if you don't have a span port, you can just put it right on a network, a normal Ethernet interface, and get a sense of what the tool will do, and then decide if you want to go for a span port afterwards. The install, there are multiple steps. If you go to our GitHub site with the Passer project, you'll see the steps there. I want to give a thanks to my colleague Ethan, who put together a Docker instance that you can install very easily. It has all of the components that you need to get it running. You need Docker, obviously, as an environment, but this will simplify the install for you. As with any packet sniffer, make sure you have permission to do the packet sniffing before you start. I don't want to see anyone coming to one of these webcasts get trouble for doing this on a network where they don't have permission. Try it at home first. If you haven't seen our home lab webcast, go ahead and swing back to that one as well. Set up a little test lab where you can try this, and it won't affect anybody.
Hey, Bill, can I hit you with some questions?
Please do.
Sure thing. So we've got a question that came in. Does it work with the concept of zero copy like NetSniff? Simply so contextualize it regarding speed and packet loss, for example. Thanks. So is it using zero copy? I don't think so, but I thought I would toss it to you.
I don't know the answer. I'm not familiar enough to answer that.
Well, what lives are you using to go through and grab packets?
Sure. The Scapy library handles the low-level capture of packets, and it uses libpcat, which is the standard library for packet capture on multiple platforms. I would tend to guess that zero copy is a different library that allows that packet capture. I think, unfortunately, the answer to that is probably somewhere in the Scapy documentation, because all I do is I simply say to Scapy, I want you to go down to this interface and start pulling packets off. I don't know if zero copy is something that's immediately available or not possible or could be made possible.
I don't believe that's part of libpcap, but if I'm wrong, I'm sure somebody will jump into Discord and correct me.
That's the best way to do it.
So the other question that came in was, how do you turn off Passer? Control-C doesn't work.
Sure. Switch to another terminal. Use PS space AX, and you'll get a listing of all of the running processes. Find the process ID for Passer in the left-hand column, and type kill space -9 space that process. And it will go away faster than you can believe.
Cool. That's it for now, dude.
Thanks much. I appreciate it. The output that you get, remember we saw those sample slides above, it's comma separated. And this is deliberately basic. We could have taken tons of different approaches for how the output is made available. In the end, this was an intentional choice to put it out in a format that almost anything can read. I don't believe you could find a programming language that can't read comma-separated input. You can load this into a spreadsheet. You can load this into a database. You can do the analysis on the command line without ever having to use an external tool like a database or spreadsheet at all. So I want to talk a little bit about how you can use this output. The first thing to understand is that the output is broken up generally into 5 columns. The first column is a 2-character code describing what's coming up on the rest of the line. So in this case, where I have TS here, as I spoke earlier, that's a TCP server. This is a machine that is listening on a port or may have that port closed. You have to check over here to find out whether it's open or closed. But the different codes here, there are only, I think, 7 or 8 of them. It's relatively short. I have a reference up on the 2 websites that we'll show you at the end. Our GitHub site, by the way, I'm going to put in the URL, github.com/activecm/passer. If you're interested in looking at this while I'm chatting, it's also on the last slide if you've seen the PDF on our Threat Hunter community Discord, or Shelby was kind enough to upload those. You can pull down the slides right now. So again, the first 2 characters on the line are the type of record. The second one is always the IP address, so that you always associate this information with one particular machine. There are a few exceptions where we just don't have an IP address, but almost always there's an IP address right there. The third column is either the TCP or UDP port, or in the case of that router line that we saw earlier, why do we believe it's a router? What did they send that made us think it was a router? So that port is unfortunately used for 2 different uses, but they don't overlap. So in general, if I'm looking at the state of a port, the port number and whether it's TCP or UDP will be listed in the 3rd column. The 4th one is the actual state. Is it open, closed? Is it listening and accepting connections? Is it a router? What is the state that we're looking at? And then the 5th one is open season. What are the details about this connection that we can pull out? So in our example where there was an Nginx server, this is where I would put that additional information. It's running Nginx, it's running version 1.10.3, it happens to be sitting on Ubuntu Linux, and we have some more information about libraries and versions following on the line. That's really all you need to know to understand how this is broken out. I'll grant you that looking at that line is not terribly user-friendly. So let's find some ways to go and pull this information together to make it a little bit easier to work with. The first thing we want to be able to do is to look at the output. So we're going to do a couple of examples with the command line. Once you've got Passer up and running, come back to this PDF and give it a try. Actually grab the log file that's being put out, save your entries to a log with a -L command line parameter, and then even while Passer's running, you can grab that file and pull whatever lines are in there out and work with them actively, and it doesn't stop Passer from continuing to add more entries down to the bottom. So the information you get will become richer and richer over time. We want to take each of these approaches. We'll talk about them up on the next slides. The first thing we want to do is actually look at the file. So if I run the command cat passer.log, or whatever log file name you picked, and pipe that into head, just showed me the top 10 lines because I've only got limited space on the slide. This will show me the first 10 lines of that file. I get the codes on the left-hand column, I get the IP addresses, the ports, the state, and the additional information over on the right. The one thing that gets a little bit annoying to me, because I like being able to look down these quickly, is when you get line wrap. So the way around that is to move on to the next slide. If I take that log file and I feed it into less, which says show me these things one page at a time, but I add the -S command line parameter, that tells less, show them to me one line at a time, but oh, by the way, don't line wrap. And what you get instead is this effect down here. You notice I have that same line, the one starting with RO right in the middle of the slide, but there's more to the right. And in order to get to it, I have to hit the right arrow key to see that. I have to hit the left arrow key to come back. But for my mind, the fact that all of these codes line up nicely, the IP addresses line up pretty well, some of the others get a little bit harder to see. We'll get to that in just a minute. This makes it much easier for me to work with it. The next thing I want to do is to pull all the entries for a single IP address together. And it turns out this is relatively straightforward once you've seen it. I'm going to give you the command, and then you can use this. I've gotten so used to typing this over and over and over again that I don't even have to think about it anymore. It's the sort command, and we're going to use each of these pieces. Let me tell you what they are. Sort would normally take lines, and they would sort in alphanumeric order from top to bottom. So all of the DNs would start up, and then you'd have TCP client, TCP service, you have router above TCP, and so on. I want to sort them by the IP address. So what I'm going to get is, I'm going to sort, I want to use the comma character as the separator, not spaces, not tabs, commas. I specifically am interested in field 2, and that is the IP address between the first comma on the line and the second comma on the line. So now sort basically skips over the 2-character code and goes right to the IP address and says, I'm going to sort by that, wherever it is. I'm going to use sorts -u field to say, let's make them unique. If you get 2 lines that have the same content, just throw the rest away. And then finally, this is the fun one. This is sorting by version number. So sort was originally written with the idea that you might have software versions stuck somewhere on a line that you have to sort by, and you want 11.2 to come after 9.5 because you're sorting by version number. And we can use this same feature to make sure that even if you have IPv4 addresses that have, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you've got 10, 11, 12, and they'd sort wrong, if you did it in alphanumeric order, they will sort correctly if you use the version number field. If you want to see how that works, run this command once without -v and once with. And you'll see how the ordering is what you would expect if you wanted to sort IP addresses and have them come together and be in the right order for IP addresses. Finally, we feed it into less-s, just like we did on previous ones. So what this does is it pulls all of the records for a given IP address together. And what you see here, we've got the first lines down to about 9 lines. I see the port numbers, TCP port 443. I see different host names that are associated with that IP address. I see the fact that this is listening on TLS version 1.2. All of it comes together. And so after you've run this for a while and you've got a big file of passer output, you can say, good, let's go and start thinking about these as a chunk. What can you tell me about the machines on my network? What ports are open? Is this a router? Does this make outbound requests? Does it have a NetBIOS name associated with it? Does it have host names associated with it? You pull all that information together. If I only want to see a few addresses, if I've got 1 or 2 machines that are of interest to me right now, then I can simply say, let's go and we're going to do all what we did before, but I'm going to limit the output to IP addresses that start with 10.0.0.17. Now watch what happens. Down on the slide, you've got 10.0.0.176 and 10.0.0.179. And as far as grep is concerned, those start with 10.0.0.17. I was actually interested in the machines in the 170 to 179 range, so this gave me what I wanted. But just be aware that if you literally want 10.0.0.17 and nothing else, you got to put a comma after 17 to say that has to be the entire IP address, not just what it starts with. This is all basic command line stuff, but the nice part is there's nothing that is outside of your ability to learn. Try it out. See what works. When you get one of these passer log files, actually try them with these commands and learn how the different commands interact with each other. So if you look on this screen, I've got 176. I can't really tell much about it. It at one point made a multicast DNS request. 179, however, look at all the information that comes out. These are different ways that my brother printer is advertising. I'm a printer, I'm a scanner, I'm available for connections on certain ports. There's even more data over here to the right about these different versions and so on. What if I'm only interested in TCP services and just the ones on my particular network? Well, I know that my network anything that starts off with 10. So over here, I'm going to look at just the entries that start off with 10 and a period. And that limits myself to just internal addresses as opposed to the entire internet. I'm also interested in ones that start off with the characters TS, comma. This caret here at the beginning of grep says the line has to start with capital T, capital S, comma. If I left off the caret, it would look for TS anywhere on the line, and it probably wouldn't change the output, but it runs more quickly if grep only has to look at the first 3 characters to decide if a line starts with TS, comma. So this is a very quick and easy way to limit the information that you're being handed to just the stuff you care about. And in this case, out comes some TCP servers that appear to be on my network, including some that are guesses. The passer isn't quite sure if there's actually a printer there. It turns out there is, but we're not 100% sure. If I'm interested in UDP services, and remember, I'm not getting in too much detail about whether they're technically servers or clients for UDP. I think we can all agree that there are some ports that are commonly used where someone connects to that port and we call the originator the client and the recipient the server, even if that's not 100% true from a network layer. What I can do is look at lines that start with US, comma, just like I did on the previous slide with TS, comma. I'm going to limit to just machines that have a 10 with a period after a comma somewhere on the line. And that does a pretty good job of limiting it just to the ones I'm looking at. I'm also going to look for the string comma open comma. And that will limit this output to just ports that appear to be open. Passer can absolutely report on services that appear to be closed as well. That's just fine. But in this case, I'm only interested in the ones that appear to be open, and here are the answers that I get. So we can find some multicast DNS, some NetBIOS. Here's a server that appears to be a bootp or DHCP server, and N2P server, and what might be an open VPN endpoint as well. If I'm interested to see what Windows or Samba or NetBIOS hosts are on the network, the code for that is NA, and that is a NetBIOS name. We have a separate code for things that come out of DNS, and that is DN. So both of them have some names that are associated with machines. Remember, NA is specifically for NetBIOS names, and DN is for things that come out of DNS records, like internet host names. In this case, I've got what appears to be a Mac Pro on the network somewhere, and some device called a Drobo 5N. Oh well, no idea what that is. We'll have to figure that out someday. I think maybe one of the most interesting uses of Passer is to put this on just a general purpose network and say, do I find some stuff here I didn't expect to see? This is, I think, one of its most powerful aspects. Do you have machines on your network that shouldn't be there? It's a good way to find them. For DNS records, we have tons of options. It will pull out a whole bunch of different record types. In fact, that's one of the heavier uses of processing power for Passer, is going through the DNS records and pulling out all of these bits of information, because it takes a certain amount of CPU time to do that. But CNAMEs, A records, pointers, quad A's, I didn't include any on the slide, but quad A's are the A records for IPv6. Passer, as I said earlier, will look for routers. And so if I'm only interested in finding about different routers on the internet, I can find them by looking for lines that start with !RO, comma, i.e. RO at the beginning of the line. And then we group all the entries together with that same sort command we're getting used to. That way you see them in basically numerical order, the way you would expect. Each one explains why we believe it's a router. There was a router advertisement. There was a time to live exceeded packet that came back in response to traceroute. There was a host unreachable packet that came back in response to some type of connection. But this way I get to build up a picture of where the routers are on the internet. Passer has some ability to identify traffic that is either malicious, suspicious, uncommon, probably not a good idea on your network. And there's never a statement that I can definitively tell you that something's wrong, but I want to give as much information as I can that something just doesn't look right. So in many cases, I can put a note in the 5th column that says, hey, there's some warnings about this particular IP address. You might want to look into why. If I have a machine that's sending SYNFIN or SYN reset packets at me with Nmap or some other type of mapping tool, Passer will detect that, and it will go and record that somebody's doing that. Some of these are where a client asked for an any record. And any record in DNS is where I say, hey, I'm interested in census.gov. Would you please send me every possible piece of information you have about census.gov? And what comes back is a very large amount of information. I think it's somewhere around 6K for census.gov. So for a very small packet, I get this massive response coming back. And in almost all cases, the attacker will have put in a fake IP address that they want the answer to go back to because they want to take out that IP address. So this is not only a request that is an amplified packet where a small request turns into a big response, but it's also a spoofed source IP where the attacker is trying to attack it. So note, 83.97.20.164 is almost certainly not sending that. They are not attacking you. They are under attack by an attacker whose IP address is very hard to figure out. There's some more down here. We have some more with it. I talk about when requests come by with a tunnel of some kind. And again, that's not necessarily bad, but if you have somebody who has set up a tunnel like a VPN and you didn't expect that, it might be worth looking into. We have a couple of minutes, so I will go through and I'm going to do a quick import example. When you have this comma-separated data, you can pull it into a spreadsheet. And I'm going to go and switch over to actually doing this live. You probably need the file with a CSV extension. So make a copy of the log file that you're working with. Pull out the records you're interested in. If you want to go and pare it down with the commands we just used, that's awesome. And then rename the output to .csv because that is an indication to the spreadsheet. This is the format of the data you're about to see. So let's give this a try. I did try it last night, and I think it worked pretty well, but just let's give this a try. I'm going to make a new Google Sheet. It is just a straightforward, empty, non-interesting Google Sheet. When I come up to the File menu and I come down to Import, it is going to think and crunch because I'm forever loading up my laptop far more than it ever should be, as Chris Brenton can very happily attest. And then I'm going to upload a file. So let's go and pick a file from my laptop. In this case, sample logs. I have a CSV file all ready to go. And it's going to ask me just before it goes, are these the right settings? I'm going to replace the current spreadsheet. I'm going to force the separator to a comma because I know it is. It actually does very well at detecting it automatically. And I'm not going to ask it to convert any data. I just want it to come in as is. When I choose import data, it takes that CSV file, it loads it up into the individual cells of the spreadsheet, and then it returns a list of all of these passer records. You'll have to adjust the widths, obviously, because most spreadsheets won't automatically give you the right width for each of these lines. The comment line in particular needs to get quite a bit wider because the comments usually take up a lot of space. But at this point, you can do searches and sorts. You can do whatever you want. If you feel more comfortable working in a spreadsheet, that's great. You've got yourself a new tool, and you can absolutely work with passers output very cleanly. All right.
Hey, Bill, you get time for a couple of questions?
100%, absolutely.
So someone asked, can you send passer data to a SIM and then create reports?
Absolutely.
I don't think, but I don't think you have a syslog facility built into passer, correct?
I don't, but the nice part is that you can take the output from passer. Passer by default spits all of these lines out to its output, its standard output. And if you feed that into a command called logger, Logger, it's part of Linux systems. I believe it's probably part of Mac as well. And put the IP address where you'd like to send those entries. Logger takes every line that it hears from passer and sends it across to that syslog server. So you can actively be feeding these directly to a syslog server live while passer is running with nothing more than a command line type logger the IP address of my SIM.
Cool.
There are a couple more command line options. Sorry.
The other question was, what's the fastest speed you've tested this out at? We've had people asking about, does this scale to enterprise? Would it be able to parse the feed of greater than 2 gigabit link? What's like the high end you've tested with this?
No chance on a 2 gigabit link. I have a little bit more on this coming up, but the short version is Passer is happy at slower speeds. If you've got a high-speed network, what you really want to do is put in a filter that says, by the way, I have these 4 types of traffic on my network that I don't care about. They are just bulk traffic. I know about them. Stop feeding me them because Passer is just getting bogged down. If you throw away the high bandwidth processes and you simply focus on all of the other stuff, you can basically keep paring that down to the point where Passer can keep up. The nice part is that even if Passer can't keep up with your link, it doesn't have to get everything. We're not trying to log every single connection with full fidelity. We're trying to get a sense of the state of these servers and services. If I lose packets, Passer continues to work just fine. It just takes a little longer then to find certain devices or certain services. So there are ways to tune it, but the nice part is Passer doesn't just roll over and die because it's busy.
Is there a switch option to only look for malicious traffic?
Malicious traffic, you can. So my best suggestion is go on to the Threat Hunter Community Discord, go on to the Passer channel. Let's talk about that, because you can pare it down to just the entries that would end up with malicious traffic. Let's go and work that out. I haven't sat down to make that happen, but you could.
Cool. And last question, when are you porting this to Windows?
When am I porting this to Windows? Chris, you got to stop putting in your own questions now.
Oh, you caught me.
It's doable.
All right, I'll let you get back to it, man.
Sounds great. Now, in a perfect world, I would have enough database background that I'd actually show you a live example of pulling this into a database. It's not my forte, and so I'm going to punt a little bit and say that it's possible to pull these lines into a database package of your choice. The steps involved, I'm sure they're relatively straightforward. It has to come in as a CSV entry. The comma is the separator between the fields. The line feed is the separator between each record, but I don't have any good examples or demos of how to do that. So come on to the Passer channel if you need some help with making that happen. We'll figure it out together. Finally, there are a couple more things that you can do. If I put -- suspicious on the command line and then I give a separate PCAP file, Passer will continue to do all the stuff that it's done, pulling in packets, analyzing them, saving the text entries out to standard out and to a log if you choose. It will do one more thing. As soon as it's recognized that an IP address is doing suspicious, malicious, weird, non-standard stuff, it records all packets to or from that IP address and all of the other suspicious IP addresses into suspicious.pcap. So what you get is a much pared down list of packets that may include the packet that looks suspicious to start with, but also everything else going back and forth to those IP addresses. It makes that, and it actually remembers those IP addresses from run to run in a text file. So you can, as you run Passer for longer and longer, you can build up this list of IP addresses that you're watching a little more carefully. I also had a request to put in a timestamp. If you add -- timestamp, it modifies the output so that columns, I believe, 6 and 7 include the raw number of seconds since January 1st, 1970, and I believe it's the written out form of the date and time when this line was captured. Back to performance, we talked about this a couple of slides ago. If you have this on a high-speed network, Passer just can't keep up with fully saturated gigabit links. It's just not designed for that. So the way to do this is either to feed it a PCAP file, let it do some post-processing, to pare down the input so that not everything is being thrown at Passer, to use a tool that fans out the full packet stream into multiple packet streams that multiple copies of Passer can listen to, or use the multiprocessor version. There'll be some more discussion about that over in a slide or two. One thing that's handy is if you've got an incident that's been going on and you want to go back through a packet capture of that incident, feed it into PCAP. The -R command line parameter says read from packets from a PCAP file. Go back and see if there's more that you can understand about what was an attacking system, or more that you can understand about a network. Save the output to a file and then review it with some of the commands that we've done right now. You may find that there were some probes that you didn't expect, or some other types of traffic going out to that target system. There's a lot you can learn about the target system from this. You can use this for system inventory. I'll be the first person in the world to acknowledge that this is not a full-fledged system inventory tool with lots of bells and whistles and imports and exports and all of the things you would want. But it's free. It works right now. It helps you understand what services are on your system, and it's a great way to get going. And a good reference, even if you have another system inventory tool. Passer-NG is the replacement version that will run as multiprocessor. We have a couple of things that Passer does not have, and that is the autonomous system number data as well as GeoIP information. It also has an active mode where it will send, if you can choose this, you have to actually add -A to the command line. But when you use it, it will actually do trace routes out to different systems. It will also actively look up things like host names for, even if nobody else has asked for a host name, it will actively go out and do that lookup itself. The reason why it's not out on the normal GitHub repository is that it's actually running a little bit thin on support. Not all of the modules have been ported from the original Passer. So on my laptop, what I tend to do is run both the current version of Passer and a copy of Passer-NG to make sure that I'm getting as much information as I can. They complement each other on what they support. For those that are interested, this was the original version of Passer from January 22nd, 2008. It was 132 bytes. And I am almost certain that on January 21st or 22nd, I saw a post about how you could write your own sniffer in a scripting language. And I thought, oh, that's cool. And thought, let's go and just put something down that would spit out, a little bit of basic information about ICMP packets. And that was the first working version. What I did find a couple of days later was a goal. This was a class that Chris and I had been teaching where there was a packet capture file, and the students in that class were asked, hey, can you tell me where the mail server is on this network? Or can you tell what outside IP address is scanning this network? And that was the student lab, and I said, well, can I make a script that will do all of these? And pretty much it doesn't quite do everything that the students were asked to do, but it comes awfully close. This leads to the final goal for Passer, and that is, what can we learn from network packets? If handed a packet, what information can I glean about that network? What can I learn that I didn't know before, and can I do it in a way that's automated? So that's really why Passer exists. As a little bit of wrap up, I do want to make a sincere thanks to Chris, Ethan, Shelby, Casey, Jason, Keith, and John, who was kind enough to join us for the call today as well, for all of the help in the background answering questions and work on Passer and help with different features. I really appreciate all the help. And everybody who's contributed to Passer or Scapy or Python or Linux, for that matter, thank you so much for the help, because I get to sit on top of that list and really look like I know something when other smart people are actually doing all the work. And what I'm going to do is switch over to the links page so that you can see these and take a look. John, what have you got?
Can you hear me?
I can. It's a little soft, but we can hear you.
All right, good deal. Let's see. Let's see if there's any questions. I got a question. What is the largest network that we've seen it running on so far?
In terms of network speed?
Oh, no, the number of systems or speed, either way. I know a couple of people are running it on gig networks for sure.
Yep.
But as far as like a 10 gig network or a 5 gig network, I don't know about that yet.
No, I don't think so. This current form is not likely to expand to a fully saturated gig link or even anything higher than that. In order to do faster networks and have a generally good chance of keeping up with them, you really want the multiprocessor version. And so go on to the Threat Hunter Discord into the Pound Passer channel, and we'll chat about that there.
Okay, very cool. John just teleported to a new office location. I respawned someplace else, I guess.
He's got one of those portal tubes, the blue and the red circle. You jump through one, you land
through one. Yep. Jump on out. All right. Chris, any more questions from your side?
No, I think we caught everything.
Okay.
Sounds great.
As usual, these tools like Passer and Rita and all these things that we're working on, they're only cool if you use them. So please go use them, contribute ideas. If you want to contribute code, that would be great. Here's one question we have to ask. Will it run on a Raspberry Pi 3?
Yes.
Yeah, I figured we'd know that one.
I'll give you 2 guesses for how I know that answer.
Yeah, absolutely. Absolutely.
It can get a little bit heavy on memory. And so your best bet would be a Raspberry Pi 4 with 2, 4, or 8 gigabytes. But it absolutely will run on a 3.
All right. Fantastic. All right, everybody. Well, thank you so much for joining this webcast. I think we have another webcast from Black Hills coming up tomorrow where we're going to talk about mentoring. And I don't know how well I'm going to do on that one. But I think Chris is going to hang out.
You'll do great.
So I'm looking forward to seeing you all there. And as always, if you are interested in a demo of AI Hunter and kind of what we do to pay the bills, instead of just writing crazy cool open source from free tools, hit us up. Go check out activecountermeasures.com and set up a demo with Chris and myself. All right, thank you so much, everybody. Get out of here. Go have a great 24 hours until our next webcast.
Thanks, folks.
Real pleasure. Thanks so much.